Alrighty, so you think you've got square roots, estimating them down so far, but we're going to take it even a step further and we're going to estimate not just between what numbers is it, but we're going to start to estimate the decimal point. Again, this is optional. You do not have to go over this content if you're not ready for it. That is totally fine. I just wanted to extend what we're learning in class just a little bit more. So if you're looking on our notebook, the first example that I give is we want to estimate the square root of 11. Remember, when we're doing these estimations, this is not the exact answer. This is by no means the exact answer. There is a way to go about calculating it exactly. It looks kind of like division, but it's not quite. I was never taught it in school. I talked to my parents. They said they never learned it in school either. But when I was in high school, I know the librarian, she told me that she had learned how to do it by hand, and it is a daunting process. So we're going to use a method to help us estimate it. Again, not perfect, not exact, but it's going to be close. So when they give you the square root, to estimate, the first thing that you're going to want to do, like you see on the steps on the side, is you're going to draw a number line. This number line is going to be like a zoomed in version of this long one that we did in the notes, a zoomed in version of it. I want to know exactly what two perfect squares the square root of 11 is between. So what is my perfect square smaller than 11? It's got to be perfect. The smaller one would be the square root of 9. Square root of 9 is equal to what? 3. So that means this next biggest perfect square would have to be the 4, and that would be the square root of 19. Oh, Andrea, 16. What am I talking about? 16. Let's fix that. There we go. So we draw a number line and add perfect square roots. The next step, or we'll do it in green. Green will be easier to see. Step 2, we want to, oh wait, we already did that. We label the bigger and smaller perfect squares. I just got excited and ahead of myself. Again, those perfect squares were 16 and 9. The next step is we want to find the difference between the smallest squares. Difference is what operation? Subtraction. That B turned into an F. Between the smallest square roots. So I need to subtract 9 and 11. What's 11 minus 9? 2. Next. Oh, step 4. My brain is not working right now. There we go. Step 4. We want to subtract the perfect square roots. Write it the way that I'm going to write it, okay? It's going to help you in the long run. So we need to subtract 16 minus 9. What is 16 minus 9? 7. Our next step, 5, we're going to create a mixed number. Mixed number approximation. I'm going to abbreviate approximation, APPX. So the way we create our mixed number, we know that the square root of 11 is between 3 and 4. So that tells me it's going to be 3 point something. So I need my whole number to be 3. This 2, I had you write it this way because that 2 is your numerator approximation, and 7 is your denominator approximation. So this is our approximation in fraction, or in mixed number form, I should say. Do we typically like to see numbers in mixed numbers? No. No, we don't like to see that. So what we're going to do is we're going to divide the fraction to get a decimal approximation. So I need to divide 2 by 7. 2 divided by 7. How many times does 7 go into 20? 2. How many times does 7 go into 60? 8. How many times does 7 go into 40? 5. How many times does 7 go into 50? 7. And as you see, this one's going to be ugly because we have a 7 in the denominator. So typically when we round, we usually round to the nearest hundredth. So if I'm going to round this to the nearest hundredth for my final answer, 8's in the hundredths place value. That 8 is going to turn and look behind it. We see a 5. What's that 5 going to make that 8 do? Jump up. So we're going to have 0.29. Is that my answer? Nope. Nope. Don't forget about that 3 out front. So it's approximately 3 and 29 hundredths. If I go on my calculator, I'm just going to do the one on my phone just because it's easy for me because it's right here. Again, the approximation, the square root of 11. This one gets 3.3166247903554. So 3.29, 3.31, 3.32. It's just 3 hundredths off. So that is a very close approximation. Use the steps that are in your notebook to kind of help you guys out. I'm going to do one more real quick, and then I'm going to have you try the bottom 2 problems on your own. The second approximation I have is the square root of 40. What's the first thing we want to do? Get 40 on that number line. Step 2 is what? Get the perfect squares bigger and smaller than 40. What are my perfect squares bigger and smaller than 40? Use your cheat sheet if you need it. 40 is between 6 and 7. 6 is the square root of what number? 36. 7 is the square root of 49. Sorry, I don't remember my colors that I used in order. I'm going to keep it the same. Red's gone, green's gone. Purple, blue, pink, yellow. Okay. What's step 3? Subtract those smaller squares. What's 40 minus 36? 4. What's my next step? Subtract the perfect ones. What's 49 minus 36? 13. Now we want to make our mixed number. Because 40 is between 6 and 7, that means my decimal point is going to be 6 point something. So 6 is my whole number. 4/13 is my fraction. Now we want to get the decimal point for it. Let's use a calculator. So if we do 4 divided by 13, we get our decimal point to be approximately 0.307692231. But again, we don't want to round to the hundredths place. So what would that round to for the nearest hundredths? That's going to round to 0.31. Is that my answer? Nope. Don't forget you got to bring that 6 down. A lot of people make that mistake of forgetting to bring the 6 down. So now let's check and see what the real approximation is for this, what the real number is for the square root of 40. we get it to be 6.3245553203336759. 6.31, 6.32. That's 1/100th off. That is very close. So this is a great method for you to do. Go ahead, try out 3 and 4, and then check it in your calculator. Let me know if you have any questions on anything. Now I gotta find out how to stop this recording 'cause it went away somewhere.